So welcome to section 2 of paper 1. Our first question is Kamau runs a charity home in the year 1999. The cost of maintaining the home was 117,000 per month. This cost was made up of food costs, staff wages, and earth charges in the ratio 4:2:3 respectively. In 2000, the cost of food and food stuff rose by 10% and 20% respectively, while earth cost reduced by 5%. These are questions that anybody can answer. If I get a class 8 student, even those who are in JSS right now, they can answer, because it is not anchored anywhere, ratio, something like that. Determine the month, determine the 1999 monthly cost of food. Just the ratio 4, which stands for food, over total ratio 9, then multiplied by the value, the total value of running a home, which gives us 52,000. This one almost everybody scored. Then we have to calculate the cost of maintaining the home in 2000. So here we are interested in getting the amount for running a home, the total cost. So we start with the food stuff, and the food stuff with is 110% because it increased by 10%. Then times over 100 times 2,000, which gives us 7,200. Wages increased by 20%. So 20%, 120 over 100 times, the ratio was 2 over 9 times 117. It gives us at 200. The earth reduced by 5%. So 95% over 3 over 9, because the ratio was 3 over 3. Then 37,050. So the total cost will be 57,000, the total of these values, which gives us 125,450. Some went ahead to multiply by 12. Some said times 12 because they were making an argument that this is per month. Now I want us to agree calculate the cost of maintaining the home in the year 2000. I did not penalize those who multiplied by 12, because they went ahead to justify that a year 2000 as 12 months, and we were getting some figure. What is the figure if we multiply by 12?
1,505,500 505 5, then 400.
400.
Yes.
There's no problem, because this one is the cost per month for the year 2000. But if you multiply by 12, you get 1,505,500 400 shillings. Still, it was okay because we did not have a specification whether it was cost per month. Sawa, eh?
Yes.
Good. Our next question. In the year 2001, the cost of maintaining a home was 153,000 per month. In that year, the cost of food and earth were 20% and 10% respectively more than those in 2000. Calculate the staff wages monthly costs in. So we know the cost. We know the cost from 2000. 2000, the cost of staff wages was at 1,200. But now it is increasing by 20% more than that of 2000. So 120,000 times this one gave us 37,440. So it is a straightforward kind of question. Now, the percentage increase in food cost between 2000 and 2001. In 2001, we want the remaining amount, because we know for health increased by 10%. So find increase for health. For earth in 2000 was 27,050. Then increased by 10%, so 110% of it. Then plus the amount for the year 2001 for staff wages. Then we subtract it from 153,000. That is amount standing for the per month in the year 2001. So we get 74,805. There are other alternative ways, but by the end of it all, we must see 74,805. That's the cost of food. So to find out the percentage increase, you find the difference between the amount in 2001 and amount in 2000 divided by 57,200, which this is the amount in the year 2000. Then you multiply by 100, you get 37.775%. Some of us went ahead to multiply to round off this one to approximately 31%. But you have not been told. So the proper answer should be, if you are not instructed to one decimal place to what, the proper answer should be that 0.78%. That is, insist on giving your answers to 4 significant figures. That's when you are going to get your answers in 4 significant figures, because the best interest here, accuracy in mathematics, mostly it is attached to 4 figures. So 4 significant figures. Don't go to this extreme of giving your answer to nearest our own number. Okay? Any question there? Any question 17?
No.
Good. We go to our next question. Question 18. Question 18. It is advisable that first of all you go through, don't rush to the diagram. Go through the information, the communication. The figure below represents a bucket in the shape of a frustum of a cone. The base and the open top radii of the bucket measure 7 centimeters and 17.5 centimeters respectively. And the height of the bucket is 24 centimeters. So now confirm whether the information has been correctly transferred to the diagram. And once you find that it has been transferred correct, the radius was 17.5, the height of the bucket was 24, and the radius was 7 centimeters. So it has been transferred correctly. Calculate the slant height of the bucket. So the slant height of the bucket, you are supposed to extend the bucket like the way it has been drawn here, so that you make from the frustum you get a complete cone. So the height of the the bucket, there are two ways. Let me give the approach of alternative, because the other one is straightforward, but we want to see the alternative. So let's find the small h here. We use similarity and enlargement approach. The big radius over the small radius, it is equals to the full height of the cone over the height of the cone that was cut off. So cross multiply, you get this one as 16. And then if we have 16, so it means the complete height will be 16 plus 24, which gives us what? The complete height will be 40. So when you have now 40 and you have this one as 16, we can find the two slant heights. The one slant height for the small cone that was cut off, and another slant height for the cone that for the complete cone. So we use Pythagoras theorem. So for 17.5 squared plus 40 squared, it gives us the slant height squared. So it gives us, once we get the square root, we get 43.6606. The slant height for the small cone that was cut off, it will be 7 squared plus 16 squared, and this one gives us the square root of it gives us 17.4. So some people stopped at this level, but the question is the slant height of the bucket. So we are interested in getting this slant height of the bucket. So slant height of the bucket will be equals to the height of the complete slant height of the complete bucket frustum minus slant height of the cone that was cut off, and it gives us 26 points. Some could have given this one to us 26.20. This one, it is even okay because it is to 2 decimal places. Insist on 2 decimal places unless you are compared otherwise. Our next equation, so we are there. Any question there? Yes, Mudeu.
I can see the screen.
Now you can see the screen. Somebody else to confirm whether you are able to see my screen. Sarah?
I can see it.
You can see the screen, eh?
Yes.
Mercy must confirm whether you can see the screen.
No, I can't.
Yes.
Mercy, do you have my screen?
No.
Maximilian, do you have my screen?
Yes.
Mercy, must check your network. Maybe you leave the meeting and you join. Sawa. All right. Let's go to the second question, part B. We are getting the volume, the surface area of the bucket. Surface area of the bucket. Now, here you should underline the 4 significant figures. Then, also, you must use the pi that you are given. Don't go ahead and use 22/7. Don't use the 24/7. Mercy, now you are able to see the screen.
No, I can't see.
Now, what might be the issue? Because others can see. The screen with the calculations.
That one is done. I cannot see.
Huh? It is the one you cannot see.
Yeah.
Okay. Let me because maybe she has joined. Let me reshare.
I can see.
You can see it now, eh?
Yeah.
Well. Now we want to find the taking pi calculator. You must go through these instructions and make sure that you listen to them well, because you have been instructed to use 3.142 and your answer should be to 4 significant figures. So we know the surface area of the bucket. The bucket was open. I think so. The base and the top radius. Are we convinced that the bucket was open? Open top, yes. It is communicated, eh? So once you listen clearly to the question and you are told that the top is what? Open. So we must adhere to that. So if the top is open, so what are we going to include in our calculation? So we need the pi r squared. This is the radius of the base. Then plus the curved surface area of the bucket. If it was closed, we were to add pi r squared. But in this case now it is what? It is open. So listen to those instructions. So this one now gives us because pi is common, we can factor it out, and once you factor out pi, you remain with r squared, so 7 squared, plus you remain with RL, the capital R, 17.5, times the L, the length of the bucket, the slant height of the bucket, that was 40. The slant height of the whole bucket was 43. 43.66 hapa kuna makosa sasa. So 43.66 minus the radius times the slant height, which was 17.4642. Something is wrong here. Replace this one with 43.6606, and then you get the answer. I think the answers were correct except this one, and your answer will be 21.70 2170.528. But remember, you are told to 4 significant figures, so your answer will be 2171 square centimeters. Are we in agreement?
Yes.
Yes. Last question. The volume of the bucket. Volume of the bucket. We know that volume is equal to a third base area times height minus a third base area times height, where the base area, if we factor out a third, pi, we remain with 17 squared times 40 minus 7 squared times 16. That's after we have factored out a third, because it was the area of the base is pi r squared. So if we factor out pi, a third pi, which is common, to minimize our working, so we are going to get a third times 3.142. That's what we are told to use. Then into bracket 17.5 squared, the radius of the bigger circle, and times 40, the height of the cone, minus the volume of the cone that was cut off, and this one gives us 12,008.724. But remember, we are giving our answers to 4 significant figures. So if that is the case, then we are supposed to give our answer to 4 significant figures. You count 1, 2, 3, 4. Consider the next number is 8, so it can add something here. It becomes 12, 0, 1. Some people stopped at this level. This is very wrong, because the number has lost value. We should maintain this 0 here, which is not significant, but it is a placeholder. It is holding the place value of 1s. So that's the number we read as it was, because the number was in terms of 10,000s. So if you leave your answer as 12 for 1, you have reduced the value to 1,000, to thousands. So the number was 12,000, so it must start reading as 12,000. So 12,010. This is our correct answer to 4 significant figures. Correct?
I have a question.
Yes.
In P, Roman 1, you have said we are supposed to use pi r squared, like we add to pi r l. If you are given a person that is open or closed, you are supposed to use the same formula by adding pi r squared.
All right. If the bucket was closed, the surface area was to comprise of the base, was to comprise of the curved surface, and was also to comprise the area of the top, pi r squared. But now it is open. So when you are asked the surface area, normally focus on what am I going to involve in calculating the area. So how many faces are there? So because the bucket was open, so one face must be left out, and the face that we are leaving out is the top. But if it was closed, we were to include the three faces: the base, the top, and the curved. But in this case, the top is open, so we don't include the top part. Ni Sara aliuliza?
Yes.
Now, is that one okay?
Yes.
Good. Another question here? We can move to question 19.
Yes.
Well. Question 19. A straight line L1 passes through A and a B. A point P equidistant from X and Y axis lies on the line AB. Find the equation of the line AB in the form. You underline the form where A, B, and C are integers. Integers are all numbers. So you must give all numbers, not fractions. If you take note, anyway, I'm not an advocate of this cramming, but it is okay. Let's find the gradient. The gradient will be equals to what? Change in y over change in x. Let's start with b. 4 minus 0 over 0 minus 3. So we have 4 over negative 3. The same as negative 3, negative 4 over 3. Alright? So once we have now the gradient, we can use the change in y over change in x, or we can use the approach of let's say use change in y over change in x. So we have the gradient, and the line is passing through one of the points 3, 0, and another point xy. That is the formal way of finding the equation of a straight line. So change in gradient is equal to y minus 0 over x minus minus 3. This equals to negative 4 over 3. Cross multiply 3y. It is equals to, because y minus 0 is just y, cross multiply negative 4x plus 12. Then arrange the equation to fit the form. Let's bring everything to the left hand side. 4x plus 3y minus 12 is equals to 0. And already it has taken the shape that we are told to have. Ax plus by plus c is equals to 0. So, but let us see the approach that the marking scheme has given us. The marking scheme is giving us the approach by identifying that A is the x-intercept because it is 3, 0. B is also the y-intercept because it is 0, 4. So this one, it is an equation that is behaving in this manner, a straight line behaving in this manner, cutting here at 3 and cutting this one at 4. So we can now give the approach of double intercept form. In double intercept form, the equation is written in the form x over a plus y over b. This equals to 1. So since we know a is the x-intercept, so we'll say x over 3 plus y over 4. This equals to 1. This is what this person has here, expressing the equation in double intercept form. Then multiply by the LCM of 3 and 4, which is 12, both sides. Then it gives us 4x plus 3y is equals to 12. Then you bring this one to this side. It gives us 4x plus 3y minus 12 is equals to 0. So this one, it gives us the equation that we intended to have. We are in agreement, eh?
Yes.
Next question, they find the coordinates of P. This one became troublesome. Let's see what we are told that B lies along the line AB, but it is equidistant. So if we draw a Cartesian, then we have this line here, which is AB. I've interchanged. This should be B, and this one A. But now the line which is equidistant from this is the line which is equidistant. The line that is passing through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, onwards. That line, it is the one we say which is equidistant. And we know the equation of this line, it is y is equals to x. So once we know y is equals to x, so the coordinates of P must be xx. That's the idea behind, that's the logic behind. That at the P, the value of x must be equal to the value of y. So having that one in mind, so now we can go ahead and substitute. So substitute these values because y is equals to x. Instead of y, we replace with x. So 4x plus 3y, but now 3y, our y is x, 3x minus 12 is equals to 0. So 7x is equals to 12 over 12. So our value of x is what? X 1 and 5 over 7. So P will have the coordinates xx. And x will be 1 and 5 over 7, 1 and 5 over 7. And that is those are the coordinates of P. Are we in agreement?
No.
Exactly where?
Where you are saying
B.
is equal to P equals to XX.
Okay, let's get back. We are doing the analysis part of the equation. If this is a Cartesian plane, this is the x-axis, this is y-axis. Then we are told here that a point P equidistant from x and y axis lies on the line AB. Meaning if this is our line AB, the point P will be along the line y is equals to x. Will be along this line, so P will be here, where we have the line AB and this is the line y is equals to x. A line that passes through the points which are equal 1, 1, 2, 2, 3, 3, 4, 4, 10, 10 as you proceed. So that line will be the line y is equals to x. That's the value of x is equal to the value of y. Alright? And this equation, this line has the equation 4x plus 3y minus 12 is equals to 0. That is the equation of the line AB. So how do you find the point of intersection of two lines? These are two linear lines. Y is equals to x and this one. We solve the two equations simultaneously. Sawa, So
Yes.
substitute the value of x, because already this equation y is equals to x. So where you see y, you can replace comfortably with what? With the x. So this one now becomes 3x. Now we get 4x plus 3x minus 12 is equals to 0. 7x is equals to 12. We have taken 12 to the other side, it becomes a positive. So x is equals to 1 and 5 over 7. After we have divided by 7, divided by 7. But now, the coordinates of this point P, it lies along the line y is equals to what? So y is equals to 1 5 over 7, because the coordinates would be the same. Have we justified our working?
Yes.
Good. That one marks the end of question 19. Question 20.
Sasa ni C.
Mm-hmm.
Na C.
There is C.
Yes.
Part C. Ah, good. Part C. Part C. L2 is another line which passes through 0, 0 and P. Find the acute angle between L2 and the x-axis. Let's demonstrate. If this is the line, x-axis and the y-axis, there is a line which is passing through 0, 0, and it is also passing through P. Studio. So this line,
Yes.
it's passing through 0, 0, and it is also passing through P. So find the acute angle L2. This is L2. L2 makes with the x-axis. This is the x-axis. So we are looking for this angle. If we drop this perpendicular line, if we drop a perpendicular line from P to the x-axis, we are going to get this one as 1 5 over 7, and this one also would be 1 and 5 over 7. In other words, 12 over 7. If that's the case, this, and considering this angle, this side becomes opposite and this one becomes adjacent. Which trigonometric ratio is measuring opposite and adjacent tangent? So tan theta, it is equals to opposite 12 over 7 over adjacent, which is 12 over 7. Are we there? Which gives us 1.
Yes.
So what will be the angle? The tan inverse of 1, which is 45. Now I want you to memorize the following. When the tan theta is always equals to the gradient. Tan theta is always equals to the gradient of the angle between the positive x-axis and the positive and the line. Angle between the positive x-axis and the line. That is always tan theta would be equals to the angle between the positive x-axis and what? And the and the line. So that is what we use. But you can go the analytical way of finding the gradient, change in y over change in x, and then you say that the gradient is equal to the tangent of the angle between the positive x-axis and the line, and then you get the tan inverse of the gradient, you get the angle. Are we in agreement?
Yeah.
Very
Yes.
good. Very good. Our next question is question 20, which is based on construction. I will just shed some light on how this construction is observed. All right. This question number 1. This question number 1. We are told to, using a ruler and a pair of compasses only, construct triangle ABC in which AB 7.5 centimeters and BC 6 and AC 4.5 centimeters. What will confirm the construction of triangle ABC? They are these arcs that I'm seeing here. There are some arcs there where you measured the length AB. After measuring the length AB, you measured AC, which is 4.5. You stand at A, you make this arc. This arc must be seen. Then you measure BC, which is 6 centimeters. You also stand at B, you make this mark. This one mark should give you 1 mark. And then you should complete. You complete the whole figure. You get other 2 marks. So there's nowhere we have used the protractor, but these arcs are very necessary. Then B, we are supposed to measure the angles of the triangle. You measure the angles of the triangle, try to be as accurate as possible. So we are supposed to measure angle BAC. According to my measurement, it is 53. You measure angle ACB. ACB is 90. But for those who had maybe 89 and 91 would score. Angle ABC, 37. But in all these angles that you have given must add up to 180. If whether it is by measurement and somebody notices that your angles are not adding up to 180, it means there is a problem. That one you will maybe miss some marks. So it is good to have this basic mathematics that the interior angles of a triangle must add up to 180. And then now bisect line AB and BC and let the bisectors meet at O. So bisecting lines. This one is not a big problem. Bisecting a line, we normally, there's a way we do. So long as you bisect line AB. Bisecting line AB, you stand at A and B. Like this one, I see somebody stood at A, made one mark here. With the same length, stood at B, made one mark here. Now standing at this one, you make this arc. Standing at this level, you make this arc. You draw, you do the same on the other side. You draw the line. Do the same here. Standing at C, you make this mark. Standing at this one, make this mark with the same radius. Then stand here, make one mark, and stand at this one, this arc. You make another one here. Stand on the same arc, this one. Then you draw. They intersect at O. Once all these constructions are done, it's not your business to know where marks are awarded. You just proceed, but don't erase the arcs. Leave your arcs the way they are because they help you in construction. And it is these arcs that will enable somebody to know you did not do the measurements or you do not use a squared. Because if you use a square, still you can draw these perpendicular lines. Next, we are using with O as the center, draw a circle and measure its radius. So now using O as the center, you draw a circle. This circle will touch A, B, C. You can see this was the process of circumscribing, which is quite basic in this case. That's all. Anything that you want to inquire on this question? Okay. Can we go to question 21?
Yes.
Good. Question 21. The graph below gives a motion of a car for some distance. It is the graph of velocity against the time, velocity time graph. Calculate the average velocity of the car or average speed. I think velocity, we are talking of average speed because velocity sometimes it is a speed in a specific direction. So that's why I thought it is wise to call it average speed of the car. We need for us to find average speed, we need total time, total distance. Whichever way you find total distance over total time. So total distance, it is the area of the graph. The area under the graph, that is total distance. So it is the area of this trapezium plus the area of this rectangle. There's a rectangle here. So we partition this graph into the sections that we can understand: trapezium, rectangle, and the triangle. So the area of the trapezium is, you can decide whichever way you will treat it. Like now, this trapezium, it is 20 plus 50 times the interval is 20, which gives us 700. And we can treat the other one as a trapezium, and we get the area will be a half times the interval between the two, 50, plus 80 plus 80 minus 20 plus 60, that 500, which gives us the total distance of 4200. Still, you can approach this one by saying it is 60 times 50, which is 300, 3000, plus a half times base, a half times 20 times 50, a half times 20 times 50, it gives us 500. 500 plus 3000, it still gives us 3500. So you can, so long as you find the area under the curve, it gives you the total distance. So once you have total distance, then we can find average speed. Average speed would be equals to total distance 4200 divided by total time. Total time started from 0 to 100 seconds. So divided by 100 seconds. So our speed would be 42 meters per second. So take note that total distance covered by the curve is the area under the graph. So find the area under the graph by all means, partitioning the area into trapezia, triangles, into rectangles. Then find the area of the shapes and add. Next is find the time the car would take to cover 3/4 of the distance. So 3/4 of the distance, time the car would take to cover 3/4 of the distance. So let's find 3/4 of the distance. 3/4 of the distance, it will be 3/4 times 4200. That is 3/4 of the distance. So this is 1 and 14. That 150. 3/4 of the distance is that 150. Once we have 3/4 of the distance, now let's find the time it will take until we get 3/4 of the distance. So to find 3/4 of the distance, let's find the 3/4 of the area will lie at what stage? 3/4 of the area. So we are supposed to calculate to find the up to this level. We have covered the distance of 700. Still, we want that 150. So what will remain here, it is that 150 minus 700. What do you get? Somebody?
2050.
2000?
450.
450. So we want this distance of 2450. We know from here to here it is 50. That is the height of this Then we want now the distance to be somewhere. So we want t. So we want t. T. How do you find this one? Will behave like what? It will behave like a triangle. It will behave. It is a rectangle. Yes. So 50 times t. This equals to 2450. What is the value of t? Divide by 2450 by 50.
49.
49.
Yes.
49 seconds. So with this 49 seconds, so we want to find the total distance, the total time taken to cover 3/4 of the journey. So 3/4 of the distance would be covered by 20 plus 49. So 49, it is from here to, but there is the first one, which is 20. So 20 seconds plus 49. So that is the approach that you give. So 3/4 of the distance will be 3/4 of 4,200, which gives us equals to, so we work out that way. Yeah? We find the first trapezium gives us 700. So what will remain will be given within this rectangle. Then we let the length to be t. Then t times 50 is equals to the remaining distance, 2450. We are in agreement?
Yes.
Yes. So the total time taken to cover 3/4 of the distance, 69 seconds. Convert the speed, 56 kilometers per hour, into meters per second. This one is normally you multiply by what? Kilometers to meters per second. You multiply by
5 over 18.
5 over 18.
Yes.
So 56 times 5 over 18. It gives us 15 and a 5 over 9. But you can still go the analytical way and you get the answer. That is B. And that's all about this question. Are we in agreement with question 21?
Our B does not read like that.
What?
Question B, it is saying calculate the deceleration of the body.
Mine is different.
Yes.
Good. Let's get back. Deceleration of the body. Let's analyze the graph. The graph, when we have a positive gradient, it stands for acceleration. Horizontal gradient, it stands for uniform velocity. Now it is moving at a uniform velocity of 50 meters per second. The negative gradient, this stands for deceleration. So when we are asked to find the deceleration, we are finding the gradient of this line. Gradient of the line. What is the gradient here? Get the coordinates of this point. 100, 0. The coordinates of this point here. 80, 50. We are in agreement, So 80, 50. So get the gradient, which would be our deceleration. Deceleration would be equals to the gradient, change in y over change in x. The final velocity is 0 minus initial velocity 50 over the final velocity is 100, the final time is 100 and it moved from 80. So this one gives us negative 50 over 20. So this deceleration is negative 2.5. When you have indicated the negative, already you are saying it is a deceleration. But if you want to bring in the word deceleration, you say the deceleration is 2.5. Now you mention deceleration. If you mention the word deceleration in your working, it means anybody will understand that it is a negative. But leave your answer at the negative level. Agreed? So if we want the acceleration gradient, which is positive, uniform speed. If we want the deceleration gradient of the negative part, the negative gradient. Sawa sawa.
Yes.
Good. Question 22. This one is not drawn. Let's skip this one. We will explain it later when we have the diagram. All right? Oh, the diagram is here. It's here with me. 1. Let's read the statements. We are told plot triangle ABC on the Cartesian plane given 2, 2, 5, 2 and 2, 5. You get 1 mark. Ndio hiyo. Triangle ABC. ABC. It's a bit mechanical question when it is a question of transformation, and it is drawn from the transformation in form 2: deflection, translation, rotation, and enlargement. So if we want to, we have drawn A, B, C. Then we go to the next instruction. We are told somebody to read the next question. Must read. B.
Triangle ABC in the line y is equals to 0 and state the coordinates of A line, B line, and C line.
You read clearly and they see that 1, you are told to reflect through the line y is equals to 0. So locate the line y is equals to 0. The line y is equals to 0, it is actually the x-axis. And the line x is equals to 0 is the y-axis. They kind of interchange. Then, using your ruler, demonstrate. Demonstration, we are using broken lines. Don't use continuous line. That A must be perpendicular, must approach the line y is equals to 0 at 90 degrees. And the object distance to the mirror line should be equal to the image distance from the mirror line. So we demonstrate to the mirror line, and then we move on the other side. So we count kind of boxes. So 1, 2 boxes to the mirror line. The other side also count 2 boxes to the image. Do the same. Demonstrate B to the mirror line. On the other side, 2 boxes. Demonstrate C to the mirror line. On the other side, 5 boxes. And then you complete this figure. After you complete, you have C prime, B prime, and A prime. You get 2 marks for drawing for doing the transformation, and for drawing the complete. The other mark now will be stating the coordinates. You can decide to state the coordinates separately, or you can come here and say 5, -2. You can state the coordinates in the diagram, but to make your diagram clear, it is good to state them elsewhere. But you can state them whether in the diagram, whether, so long as you state the coordinates. 2, 2, -5. That's what to do. All right, next question. Mass, the next question.
Enlarge A line, B line, C line by scale factor of -2. Center 0, 0 and state the coordinates of A line, B line, C line.
K is equals to -2. There are two things that we said to note. When the scale factor is negative, it means that the object and the image are on either side of the center of enlargement. So the center of enlargement is 0, 0. So the object, the image must be on the other side of the center of enlargement. So we are supposed to join object. Our object is A prime, join it to the center and extend the line. C to the center, extend the line. B to the center and then extend the line. Let me have somebody. Just demonstrate to the center, but always use broken lines. Then extend the other side. Then take your pair of compass. Pair of compass stand at the center. Stretch your pair of compass to A prime. Along the line you extended, count twice. So you count twice. 1, 2. Your point will be here. After counting on the other side twice the distance. So stretch your pair of compass from the center of enlargement to B prime. You move to the other side, you count twice. So 1 and then 2. That's where your B prime is. Do the same. Stretch your pair of compass to C prime. Move to the other side. Count twice. 1, 2. And then you will be at state the coordinates. I have said you can state the coordinates here in the diagram, or you can state the coordinates elsewhere. But to make sure that your diagram is neat, it is good to state the coordinates elsewhere, not within this. All right. Next question. Maxi, read for us next question.
Rotate triangle ABC to 180 degrees about 0, 0 and state the coordinates of A line, C line.
So rotate the triangle. One, we locate the object ABC. Then we want to locate the center. The center of rotation is 0, 0. Get the angle of rotation. Join A to the center of rotation. You measure the angle, which is 180. It will proceed as a straight line. The distance from the center of rotation to the object is the same as distance from the center of rotation to the image. This one is easier. You do them same case. Join C to the center, extend the line because it's 180 degrees. then the object distance equals the image distance. Do the same with the B to the center, extend the line on the other side, then B prime, because the angle must be what? 180 degrees. Then you state the coordinates either in the diagram or you state them elsewhere. That's all about this basic transformation. Our next question, question 23. Statistics question. The data below shows marks scored in a test by a group of students in a class. Marks scored and the number of students. We have the table. We are told we don't know the number of students. Given that the mean mark is 28, calculate the value of k, hence the total number of students. So let's go to the process of finding the mean. For us to find the mean in grouped data, we need the midpoints. That will stand for x. We need fx, frequency times the midpoints. So we find fx, then the total, the sum of fx, which will be 995 plus 28k. Then to find out the mean, it will be equals to the sum of fx over the sum of f. So 995 plus 28k over 35 plus k, the sum of f, tunaongeza easy, 35 plus k. And then we cross multiply, we work out for the value of k, which gives us 15. Are we in agreement? You can follow through. State the model class. So that now we have this one as 15. What will be the model class? The model class is the class with the highest frequency. So the model class will be 27 to 29. That has a frequency of 15. State the model class and the model frequency. So model class is what? Model class is 27 to 29, and the model frequency is 15. We calculate the median mark. Number one, when we are working out for the median, we need the cumulative frequency column. So make sure that you get the cumulative frequency column. That will normally award you 1 mark. After getting the cumulative frequency column, state the formula for finding the median. Formula for the median is equals to LB, the LB, lower class boundary of the median class, plus n over 2 minus c over f times I. So once you state the formula, locate the LB, n over 2, c, and then f, then interval. So you divide our n is 50, n over 2, 25. You go to the cumulative frequency column and find the first value that will accommodate the 25. So for 17, still 17 is less than 25. 32 is higher than 25. So the first figure along the cumulative frequency column that is greater than, that is equal to n over 2 or greater than n over 2. So we circle this one. This is where this is our median class. So our median class. So we get the lower class boundary of the median class, which will be 27 minus 26, 1, divided by 2, 0.5. So 26.5. So 27 minus 0.5, which is 26.5. Then C, this is our C. This is our F, which is 15. And the interval is 29.5 minus 26.5. I think 4. Yes. Now let's go to substitute in the formula. Yes, 3, not 4. Let's substitute in the formula. L lower class boundary 26.5, 50 over 225 minus 17 cumulative frequency above the median class divided by 15, which is the median class. 29.5 minus 26.5, 3. Then you evaluate and you get your answer as 28.10. Are we in agreement?
Yeah. Number 23. Our question is about angle.
Oh, I have a different question.
Yes.
Okay. Hiyo tutaifanya baadaye. Sawa? I'll do
Yes.
when we have the diagram. I'll get the diagram, then we discuss about it.
Yes.
So tomorrow, make sure that you bring it on board so that we take a photo, you send it to me, then we will start with that one tomorrow before we do section 1 of paper 2. All right, but at least you have seen statistics how it is.
Yes.
Next question, question 24. Do we have the same question now?
Yes.
Good. Well, complete the table below for the curve. We substitute and work out. Substitute the value of -2 in this one, in the function. Then you fill the table completely. We can learn on how to use a calculator to feed in the information with the brackets, and then we get the answer. Then we transfer the same figures to the, so learn on how to use a calculator to give the information, to give the figures directly. So we have perfectly worked out for the table. Then we want to do plotting. We start plotting -2, -6. This one. -1, 0. (0,4) and 1,6. Then we have 2,6. So my point of interest is here. The turning point must be treated very well. When the 2 points, let me make it a little bit, when the 2 points are actually at the same level, we have plotted 1,6 and 2,6. and then you are drawing it. Make sure that you consider this one appropriately. The turning point must be smooth. Kuna wenye wanakuja wanaanza fika hapa wanasema tu hivi, then it proceeds. This one is wrong. So it must be made smooth, either by getting the midpoint of 1 and 2, which is 1.5, or you move to the first, you touch the first line, the first small box as you turn. I think that one is appropriate. Not necessarily getting the midpoint, because the midpoint will also land you somewhere there. So you get the first, you move to the first box, that line, it is just touches and it gets back. So that curve will be smooth on the turning point. Now with this one, after you have drawn, you get your marks. Make sure that you draw something smooth. Use your graph in B above to solve the quadratic equations. We always subtract. We must work hard to eliminate the x squared. Eliminate the x squared. So we subtract the function that we used to draw the graph minus the equation we are solving. Then you observe whether if you subtract, are you going to get the value of x squared 0? That's our interest, to get the value of x squared 0. So if we subtract y squared, y is equals to minus x squared plus 3x plus 4. 0 is equals to, this is the equation we are solving, subtracted 2. And then you draw you get y is equals to 0. Draw this equation, draw this line y is equals to 0, which is the x-axis. So we want to get the values of x where the line is cutting the x-axis. So it cuts the x-axis at -1 and at 4. Where the line is cutting the x-axis at 4 and at -1. We take the values of x. So x is equals to, x1 is equals to -4 and x2 is equals to 4. We do the same in the next equation. We are using this one to solve x squared minus 5x. Rearrange the equation that we used to draw the graph, this function. Minus 0 is equals to -x plus 5. Subtract 4 minus 0, 4. This minus 2x is equals to y. Make a table of values. When x is equals to 2, y is 0. When x is equals to 0, y is 4. Then draw the line. Draw the line y is equals to -2. Find the points where the line will cut the graph. Find the values of x. So this one gives us x is equals to 5, and here the value of x, it gives us 0. So x is equals to x is equals to 0, or x is equals to 5, and those are the values. So you draw and you take the values where the line will cut the x-axis. Yeah, the line where the line will cut the curve, and that one marks the end of the section 2 of paper 1.